You may leave at some other class. Okay. Yeah.
Yes, sir.
We have done last class.
So we have done principle of homogeneity.
Just wait for 1 minute. Let the other student to join. Tell me the last question which we had last class.
Yes, it is coming. So we have done a question in which we have to take out alpha, beta, and in which alpha was equals to energy upon x and beta was equals to alpha upon p.
Now the next term is to define. Just 1 minute. Application of dimensional analysis. Ellen, do you have any doubt from the last class?
No, sir.
Now, the next part is to define application of dimension analysis. So we have mainly three different applications. First is checking the correctness of equation, or we may call it as the defining consistency of equation, for which you have to take the dimension formula of left hand side of the given formula, and similarly dimension formula of right hand side. If dimensional formula on either side would be equal, then we can say it is dimensionally correct. So the equation would be dimensionally correct. I'm giving one example. Suppose if you have half mv square, which is equals to mgh. First of all, try to define the dimension on left hand side, and similarly try to define dimension on right hand side. So we have in LHS, which is half mv square. Similarly for right hand side, we have mass, gravity, and height. Just try to calculate dimension on left hand side and right hand side. Okay, try to calculate, everyone. Good, Ifra. Ellen, send your answer. Fawaz, do you have any doubt?
Sir, can you explain me what to do in this?
We have to define the dimension of left hand side and similarly define dimension on right hand side. Just try to calculate dimension of this part and this part.
Okay.
Ellen, should I solve? Okay, just see, we have half, which is dimensionless constant part, so we can neglect it. Next is mass, so we can write capital N. Next is velocity, which having dimension LT minus 1 and square of it. So it will become m L square T minus 2. So this will be your dimension for left hand side. Similarly, if you calculate for right hand side, the first term is mass, so you can write capital M. Next is gravity, which is nothing but LT minus 2, and H being calculated in terms of length, so it can be capital M. We have length here and we have length here. They are in multiplication, so their exponential will be added. So it will give you L square T minus 2. Is it clear for us?
Yes, sir. Yes, sir.
Just compare whether the dimension on left hand side and the right hand side are equal or not.
Equal, equal.
So we can say this particular expression is dimensionally correct. Okay.
Yes.
So this equation is dimensionally correct. Is it clear, Ellen?
Yes, sir.
Okay, just write it down. Fawaz, have you done?
Yes, sir. Done.
Okay. Now I'm defining you on this particular basis. Let's say if you have 3 by 2 m times of v square, which is equals to 5 by 7 mgh. I'm just defining any equation like this. So if you calculate the dimension formula of this and dimension of formula for this, it will give you ml squared t minus 2. And this will again give you ml squared t minus 2. So again, we can say this is dimensionally equal. So this expression would be correct according to dimension. Okay. Is it clear, Ellen?
Yes.
But numerically, these two equations are not correct. For kinetic energy, we would have just half in the coefficient of mv square. And for potential energy, it would be just 1. But here we have 3 by 2 and here we have 5 by 7. So we can say this is in actual not correct, but dimensionally this equation is correct. So from this we can conclude a dimensionally correct equation may or may not be correct on the behalf of their proportionality or coefficient term. But if an equation is dimensionally incorrect, it will be always wrong. Is it clear?
Yes, sir.
Okay, so we can say dimensionally correct equation may or may not be correct but a dimensionally incorrect equation is always wrong. Is it clear to everyone? Just write it down. Try to solve for this part. Velocity is equals to root under 3 times p by rho. In this equation, v is velocity, p is pressure, and rho is density. Try to solve. Square root in terms of exponential can be written as power half. Try to solve, everyone. Whether this expression is dimensionally correct or not. Ellen, any doubt? Fawaz?
No, sir.
Okay. Good, Ifra. Dimension formula of velocity is LT minus 1. Dimension formula of pressure is ML minus 1, T minus 1. And density is mass per unit volume. So it would be mL to the power minus 3. Ellen, should I solve? Pavas, just see. We have velocity is equals to root under 3
Sir,
times
this is
T.
Vaishnav, sir. Sorry, because of some network issues, I cannot join, sir.
Okay, no problem, no problem. We have left hand side as velocity, so we can write in LHS as LT minus 1. Similarly, for right hand side, first we have square root. So in terms of exponential, we can write it as plus half. In numerator, we have 3, which is dimensionless numerical part, so we can neglect it. P is pressure, which can be written as ml minus 1, T minus 1. And rho is density, having dimension ml to the power minus 3. Is it clear, Ellen? Just compare m and m would cancel out. We have L to the power minus 3. So if you move this particular denominator to the numerator, its power would become positive 3. And we have already power as minus 1 in numerator. So plus 3 minus 1 becomes plus 2. So we're left with L to the power 2 and T to the power, I think it is minus 2. And whole to the power half. We have a relation if x to the power m and which is further raised to the power n, then these two exponential would get multiplied. Similarly, we have L raised to the power 2, which having further exponential as half, so it will get multiplied with each part. So it will become L to the power 2 into half and P raised to the power minus 2 into half. This 2 and this 2 would cancel out, so we're left with L. This 2 and this 2 cancel out, so we're left with just minus 1. Is it clear for us?
Yes, yes, sir.
Just compare the dimension on right hand side and left hand side. Are they equal or not?
Yes, it is.
Yeah.
It is.
So we can say it is dimensionally correct. Okay. Ellen?
Yeah.
Okay. Just write it down. Vaishnav, we are dealing with application of dimensional analysis, in which the first part is to define on the basis of dimension, check whether the given equation is dimensionally correct or not, for which we have to calculate dimension on left hand side and dimension on right hand side. If the equation on left hand side and right hand side dimensionally becomes equal, then we can say it is dimensionally correct equation. Okay, Vaishnav?
Yes, sir.
Okay, just write it down. Yes, Fawaz?
It is done.
Okay, good. Vaishnav, have you written?
Just a minute, sir. Finish, sir.
Good. Now the next part is to define conversion of unit from one system to another. But let's say first method is to define system of unit. We have mainly different types of unit in which we can measure a particular quantity. First, which is CGS unit. Second, MKS unit. Third, FPS unit. And last, which is internationally accepted as SI unit. CGS means centimeter, gram, and second. Measurement of length is in terms of centimeter, measurement of mass in terms of gram, and measurement of time would be in seconds. So it will be called as CGS unit. The larger unit regarding this particular term would be MKS, meter, kilogram, and second. The next term is FPS, foot, pound, and second. Since the oldest branch of physics is mechanics, and in mechanics we deal with just three terms, mass, length, and time. So in initial days, the unit were assigned to define only just three terms, mass, length, and time. That's why we have just three terms to define mass, length, and time, mass, length, and time, mass, length, and time. But due to advancement of physics, some more quantities were enrolled in those fundamental quantities. So we assume this particular SI unit as internationally accepted, which contains 7 different fundamental quantities. So we have certain limitation regarding this unit. Let's say for first FPS, 1 foot is equals to 12 inches and 1 inch further equals to 2.54 centimeter. So if you want to convert foot in terms of meter, let's say 2 foot and 5 inches. So it will give you 2 into 12 plus 5. So 2 into 12 becomes 24 plus 5, which is 29 inches. Each inch would be equals to 2.54 centimeters. So we can multiply it by 2.54 centimeter. So it will convert in terms of centimeter. If you divide this whole term by 100, this whole term would becomes or would be converted in terms of meter. Is it clear to everyone? This is in terms of foot. This is in terms of inches. So I have converted this whole term in terms of inch only. Now to convert inch, we have to multiply this particular term by 2.54 centimeter. So this will get converted in terms of centimeter. But now I have divided by 100, then whole term would be converted into meter. Now just see, on conversion of this to this, we have to multiply so much different constant part. 2 into 12 plus 5, then 29 into 2.4, then divide by 100 to convert this particular value in terms of meter. SI system of unit tells you if you have to convert from one multiple to the other multiple, just use the power of 10 instead of using this numerical value. Just if you have 10 raised to the power 0, 10 to the power minus 1, minus 2, minus 3, minus 6, minus 9, minus 10, minus 12, and so on. Similarly, 10 to the power plus 1, 2, 3, 6, 9, and so on. So these terms have certain, just 1 minute. Ten to the power minus 12 and so on. So if this is your base quantity, if you're measuring in terms of mass, length, volume, current, or any of the given quantity, this will be called as base. This is deci, centi, milli, micro, nano, eco, and so on. 10 to the power 10 would be always in terms of length. It is called as angstrom. Similarly, the larger term would be deca, hecto, kilo, mega, giga, and so on. So if you're using length, so it will be centimeter, decimeter, millimeter, micrometer, nanometer, picometer, and so on. If you are calculating in terms of mass, it would be centigram, milligram, microgram, nanogram, and so on. So this base quantity will define that particular measurement, and you have to use these terms as their prefix. Is it clear to everyone?
Yes, sir.
So a system of unit tells you if you have to convert multiples and submultiple, just use power of 10. As like if you have to convert this value in terms of meter, you have to multiply and divide by this so much value, which will take you so much time, or it will be quite hectic to solve this much numerical value. That's why we adopt this SI unit as internationally. Just write it down. Rashna, any doubt?
No, sir.
Done.
Was done.
Yes, sir.
Rashna,
Yes, sir.
okay. So how to convert system of unit from one to another? So the next application is conversion of unit from one system to another. Let's say if you have 5 meter as physical quantity. So if you convert this particular term in terms of centimeter, it will give you 500 centimeter. Now, if you want to convert this particular 5 meter in terms of kilometer, it will give you 0.05 kilometer. Is it clear to everyone?
Yes, sir.
Okay. Just see from this part to this part. If you are going from meter to centimeter, we are just decreasing its unit, as meter is larger unit and centimeter is smaller unit. So we are just decreasing the unit. Now just see the numerical part. It is getting increased from 5 to 500. So we can say it is increasing. Similarly, if you move from meter to this kilometer, kilometer is larger unit and meter is smaller unit. So we are actually increasing the unit. Now just see the numerical part from 5 to 0.05. So it means the numerical part is getting reduced. So we can say this part is decreasing. Now from this we can conclude, if we decrease the unit, numerical part could increase, and if we increase the unit, numerical part could get decreased. Is it clear to everyone?
Yes, sir.
Yes, sir.
Alan, any doubt?
Sir.
Okay.
No.
So just see how these two terms being related. If you increase first term, the other term would get decreased. If you decrease this word first term, the other term would get increased. So we can say these two different values are related inversely. If one of the quantity is increasing, the other quantity is being reduced. If one of the quantity is decreasing, the other getting increased. So we can say these two different values are related by inverse relation. Is it clear, Vaishnav?
Yes, sir.
Okay, so we can say here I'm defining two terms. First is numerical part, and second, the unit in which that given quantity is calculated. So if you are increasing numerical value, unit get decreased, and if you are decreasing the numerical value, unit would increase. So we can say numerical value and its specified unit are related inversely to one another. If you convert this particular proportionality term by any constant, let's say it would be k divided by u. If you move this u to the other side, it will becomes n into u is equals to some k, which is constant point. Is it clear? Suppose if you have any physical quantity represented by x, so it will have one numerical value and the next its unit. The product of these two different terms is always constant for any of the given unit. So we can say numerical value and unit in first system of unit would be equals to numerical value and unit in second system of unit. Is it clear?
So can you please again repeat it?
Since the product of numerical value and its unit is always constant for any of the term, let's say 5 meter, 5 is numerical value and meter is SI unit. If it is converted in terms of centimeter, it will become 500 centimeter. So are these two terms are equal or not?
So they are equal.
So we can say 5 meter is equals to 500 centimeter is equals to 0.05 kilometer. It means N1U1 is equals to N2U2 is equals to N3U3.
Okay, sir.
Is it clear, Ellen? Okay. Now the next part is to define. We can convert this particular unit in terms of dimension, as dimension describes you nothing but the SI unit related to given quantity. So we can write unit in terms of dimension as m raised to the power x, l raised to the power y, and t raised to the power z. Now put the value of unit in terms of this in this expression. So it will be n1 u1, that is m1 l1 and t1 to the power x, y, and z is equals to n2 m2 l2 and t2 to the power x, y, and z. Now from this we have to calculate the value of n2. So move this down to the other side. So we're left with n2 is equals to n1 m1 divided by m2 whole to the power x, l1 divided by l2 whole to the power y, and t1 divided by t2 and whole to the power z. So this will be your final expression to convert the value of one system of unit into another. Is it clear, Vaishnav?
Yes, sir.
Ellen, any doubt? Okay, just write it down. I'm defining how to calculate or how to convert values from one system to another.
sir, done.
Vaishno, done?
Just a minute, sir.
Okay. Vaz, you may take a screenshot.
Yes, sir. I took this.
Good.
Finish, sir.
Okay. Let's say if you have to convert 2 Pascal pressure into a system in which mass, length, and time is measured as 100 gram, 10 centimeter, and 10 second respectively. So how to convert this? Just see the first part, what we have to convert. So it is 2 Pascal pressure. So we can write pressure is equals to 2 Pascal. So this particular 2 would be numerical value in first system of unit. So we can write N1 is equals to 2. Second, define the dimension of this particular pressure. So pressure is M L to the power -1 and T raised to the power -2. So M raised to the power nothing but 1, which can be related as X. So we can write X is equals to 1. Y is the exponential of L. So it would be -1. And Z is exponential of T. So it would be -2. So from this first part, I have defined this term. Now the next part is to define the conversion table. Conversion table. We have just see in this particular part, we are defining term in terms of SI unit. So we can call this particular term as SI unit. The new term in which we have to convert, we call this particular as new unit. In SI unit, mass, length, and time. Mass would be converted in terms of kg, length would be in meter, and time would be in second. Now, check the quantity which is being measured in second unit. So mass is measured in terms of 100 gram. So we can write N2 is equals to 100 gram. Length is in terms of 10 centimeters. So we can write L2 is equals to 10 centimeters. And time is calculated in terms of 10 seconds. So T2 would be 10 seconds. Is it clear to everyone?
Yes, sir.
Fawaz, is it clear?
Yes, sir. Yes.
Okay. Now just compare whether the unit on left hand side and right hand side for each term are equal or not. Just see for mass. We have 1 kg in left hand side, but we have 100 gram in right hand side. So these units are different. So we would convert this particular kg in terms of gram. So 1 kg is equals to 10 to the power 3 gram. Similarly, here we have 1 meter, but here we have 10 centimeter. So just convert meter in terms of centimeter. So it will be 10 to the power 2 centimeter. Now just see, here we have just 1 second and here we have 10 seconds. So they are equal. So we don't need to convert. Okay. Vaishnav, is it clear? Alan? Okay. Now just write the formula. So we have N2 is equals to N1, M1 divided by M2 to the power X, L1 over L2 to the power Y, and T1 over T2 to the power Z. Now put all the values of these terms and simplify it to get the value of N2. Try to solve. First, write it down and try to put all the values in the given expression.
Yes, Maya.
Vaishnav, try to put all the values in the given expression and simplify it. Should I solve? Ifra?
1 minute, sir.
Yes, sir.
Just see how to simplify it. N1 is nothing but 2. So just put the value of N1 here. M1 is 10 to the power 3 gram. So we can write 10 to the power 3 gram divide by M2, which is 100 gram. So it will be 10 to the power 2 gram and whole to the power X, which is just 1. So this is all about M. The next part is L1, which is 10 to the power 2 centimeter divide by L2, which is 10 centimeter and whole to the power Y, which is -1. The next part is time. T1 is 1 second and T2 is 10 second and whole to the power Z, which is -2. Now, just simplify it. So it will be 2 into 10 to the power 2 and 10 to the power 3. So we're left with just 10 to the power 1 into 10 to the power 1 and 10 to the power 2. So it will be 10 to the power 1. But if it is further multiplied by this -1, it will become 10 to the power -1. Third part, we have 1 upon 10 and exponential as -2. So if you convert or reverse the fraction, the exponential would becomes plus. So it will become 10 by 1 to the power 2. So it will be 10 to the power 2. Is it clear to everyone?
Yes, sir.
Yes, sir.
Fawaz, any doubt?
Sir, what to do with seconds? 1 second by 10 seconds. How?
We have fraction 1 divided by 10. So if a fraction gets interchanged, means numerator move to the denominator and denominator move to the numerator, then exponential would change its polarity. So we have -2 here. So on reversing the numerator denominator, this will becomes +2. Okay.
Okay, okay.
Now just check all the different exponential. So we have 10 to the power +1, 10 to the power -1. So these two terms would cancel out. So we're left with just 10 to the power 2. So it will be 2 into 10 to the power 2. So this will be your value for N2. So how to write the answer of this particular conversion? It should be written like 2 Pascal is equals to 2 into 10 to the power 2 in terms of new unit. Is it clear?
Yes, sir.
Okay, just write it down.
Sir, done.
Okay. Fawaz done.
Yes, sir. Done.
Vaishnav.
Yes, sir.
Okay. I'm giving you one more problem regarding this. Convert 5 joule energy in a system in which mass, length, and time is measured as 100 gram, 10 centimeter, and 10 second respectively. Just use the same relation as we have done in last problem and try to simplify it. Okay, just I'm checking. Good, Ifra. Fawaz,
Yes, sir.
what we have to convert, this is
Energy.
energy.
5 joules.
So energy is equals to 5 joule. So what will be your numerical part in first term?
N1
The value of
equals
N1
5.
is
5.
good. And dimension formula of energy would be ml square t minus 2. So we can say x is equals to 1, y is equals to 2, and z is equals to minus 2. Now just put these values in the same expression we have done for this part, as the conversion table would be remain same. Okay, so just use the same conversion table and try to define the value of n2. So it would be m1 divided by m2 to the power x, L1 divided by L2 to the power y, and T1 divided by T2 to the power z. Try to put all the values and simplify it. Alan, have you solved? Just put all the values in the given expression. Using the conversion table of last question. Should I solve? Vaishnav, just see, here we have N1, which is equals to 5. M1 is in SI unit. So if you convert in terms of gram, it will be 10 to the power 3. Divide by M2, which is 100. So we can write 10 to the power 2 and whole raised to the power x, which is 1. Similarly, L1 is in term of meter. So if you convert it in terms of centimeter, it will be 10 to the power 2 centimeter. L2 would be just 10 centimeter, whole to the power y, which is equals to 2. Similarly, time 1 second divided by 10 second and whole to the power z, which is equals to -2. Now try to simplify it. Alan, check your calculation. Vaishnav, have you solved?
No, sir. One.
Avaz, let's see, this gram and this gram would cancel out. We have 10 to the power 3 here and 10 to the power 2 here. So it will be left with just 10 to the power 1. Similarly, this 10 and this 10 to the power 2 would cancel out. So it would be 10 to the power 2. And if we reverse these two terms, numerator to denominator and denominator to numerator, it will become +2. So it will become 5 into 10 to the power 1 10 to the power 2, 10 to the power 2. Alan, try to simplify it.
What?
Just simplify this expression. So on simplifying, it will become good, Alan. Fawaz, send your answer for this simplification. Vaishnav,
Yes, sir.
what will be your answer on simplification of this?
5 to the power of 10 into the power of 5.
Good. So we can write 5 joule is equals to 5 into 10 to the power 5 in terms of new unit. Okay. Is it clear to everyone?
Yes, sir.
Fawaz, any doubt? Fawaz? Alan, do you have any doubt in this whole topic? Okay, so this is all about the conversion of unit from one system to another. Okay, we'll just stop here. In next class, I will start how to deduce a relationship between different physical quantity and try to obtain the formula related to that particular given quantity. Okay.
Yes, sir.
Okay, then we'll meet in next class. Vaishnav, do you have any doubt from today's class?
No, sir.
Okay, then